Hello and welcome to this podcast for Electropages. I'm your host, Robin Mitchell. In today's special episode, we are joined by Gary Beckstedt from Flip Electronics. And if you remember, he was with us on a previous episode. So say hi to the audience.
Good morning, Robin. Thanks for having me, and good morning, everyone.
Fantastic. It's great to have you back. Now, just before we jump into the topics for today, which is all about counterfeits, I just want to quickly have a special word to our audience as a bit of a remembrance thing. I'm sure we all heard, but the Z80 processor was made redundant. It's been discontinued. And so I imagine that Flip Electronics might be buying a couple of those wafers. Would that be the right thing to assume?
Well, I don't make those sort of purchasing decisions, but I am sure that if there's interest and availability, we'll be on top of it. Yes.
Fantastic. And I think now we should have a minute of silence for that processor. Right, now that minute is done, let's get straight into the topic for today, counterfeits. Now, last time, if I remember correctly, we sort of discussed about the dangers that counterfeits pose on engineering. And I think one example that was quite interesting was the one about the ejector seat from the fighter plane. So just for the audience out there, could you recap what was actually going on in that situation?
Absolutely. So that was the tragic death of Lieutenant Schmitz, the United States Air Force. He was bringing in his fighter jet on a final approach and had a mechanical failure that required utilization of his emergency ejector seat. The seat ejected from the aircraft fine. Unfortunately, the controller board that was designed to launch his parachute failed to operate, and Lieutenant Schmitz summarily fell to his death. A subsequent investigation determined that there were, in fact, several ICs on board the controller board that displayed characteristics of counterfeit electronics, including resurfacing and abrasion marks. This is unusual because typically we don't see counterfeits at the root of a formal investigation. His widow has summarily launched lawsuits to further the investigation, which I think is why we've heard about it more than any other reason. Typically, manufacturers and distributors try to not be so public with acknowledging counterfeit usage. So,
so just in that case, is this, or would it be right to say this is the first recorded case of like a direct link between counterfeits being discovered and somebody dying, or is this happened before but not really been publicized?
It's happened before and not been publicized, but it's also not the first that was publicized. In my ebook that Flip has produced, I list a couple of examples, one of which includes a young Vietnamese woman who was killed tragically by electrocution when she was asleep in her bed and rolled over onto a counterfeit USB charger for her iPhone. The charger was improperly manufactured and it was actually transmitting full mains electricity down the cable. And so when she rolled over onto it, she was electrocuted. There was another example of a woman who was electrocuted, again, using a phone that was charging when she answered a phone call and pressed it to her head and then received the full shock through her head through that usage. So it's rare that counterfeits are acknowledged as being the root cause, but it is not unheard of.
It's not unheard of. You see, that's quite interesting, because I think it's well established that chargers, especially for battery chargers, have been notorious for the past sort of 10, 20 years, failing in the worst situations and causing massive fires. And we've seen this with a lot of those e-bikes and e-scooters, where people you get them for about $1,000 on Amazon, you charge them up, and because the manufacturing quality may not be great, the batteries tend to explode and then ends up burning the whole house down. But is that a result of bad engineering, or is that, do you think, more of a problem with counterfeit parts?
It could be either. I think back to the number of earlier phone devices where the lithium batteries were overcharging and summarily catching on fire. That may have been the result of poor engineering. On the other hand, counterfeit electronics in use in a perfectly designed, engineered product can result in these sort of catastrophic failures. I remember my first, what I believe is my first experience with counterfeit electronics was back in the very early 90s. I was working for a research and development firm, and we were building circuit boards, and I ran across a set of chips that failed on test. And at that time, being totally unfamiliar with the concept of counterfeits, I attributed it to a bad manufacturing date code. And so for a couple of years
Hmm.
after that, when I would order these parts, I would specifically order them and exclude that date code range.
Yeah.
In subsequent years, learning about counterfeits, I began to realize that these parts were probably counterfeits and it had nothing to do with the date code or the manufacturing. And I
Hmm.
think that a lot of people may fall into that same range.
And I think obviously there's lots of aspects to a counterfeit as to how it can affect a project or affect human lives. But it's interesting that you mentioned that, because it's also that I can imagine a younger self would be working on those boards, banging your head against a wall, thinking, "Why is this thing not working?" Because you would assume the chips would be fine,
Yeah.
and that it might be something else that's failing, but you'd never really suspect that it's the chip itself that's actually not behaving as expected.
Well, and it's an interesting concept because statistically speaking, less than 0.1% of any electronic component is going to fail in normal usage. Yeah, you
Hmm.
have the scenarios where if you're exceeding the specified life capabilities of the part, either through temperature, vibration, radiation, etc., you may experience failures. But just in the normal course of things, you don't expect electronics to fail. It's almost a
No.
solid. As long as the circuit's designed well, everything should be perfect. So when you do see a consistent failure across a single device like I was seeing at that time, it is a little disturbing, and it requires that kind of investigation.
And during that project, how long did it take you to sort of get around that situation? Because I'm kind of thinking of in terms of how much money it would have cost your project in wasted time because that part was wrong in the first place.
Yeah, that when it comes to counterfeit calculations, I think that's something that gets overlooked sometimes. We think about
Hmm.
how much money we spend buying the replacement parts and fail to calculate in the repair costs. In that situation, it was a case of it only took me a couple of days to determine the exact problem on the board and
Hmm.
isolate it to that specific date range of chips. But we did have to manually go in, remove the parts, purchase replacement parts, and then manually place those rather than just having good parts going through the reflow during the initial manufacturing production run. And that took us several weeks of repair.
And considering its research and development, I would also assume that the distributors that you would have used to source those parts would have been respectable. So it must also be equally frustrating for someone like you that you're working on this really expensive project and you find that somewhere down the line the supply chain has provided you with bad products.
Yeah.
And 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 luckily in your situation, I imagine it wasn't a safety risk, unlike the ejector seat in that fighter craft. But had that been the case, we see what happens. Somebody ends up getting killed. So how did you feel when you kind of came to the realization that it was counterfeit parts that you were dealing with?
Well, again, the realization came several years later. I was no longer with that
Mm.
company, but it was a case of what other parts am I dealing with, and where are the risks that I'm exposing myself and my
Mm.
downstream customers to by trying to save a little money here or meet a deadline there when legitimate known parts aren't necessarily available. And I think that
Mm.
at that time, that really started stoking the fire of passion I have on dealing with and helping companies mitigate the risks of counterfeits within their own supply chain.
And and speaking of supply chains, this could be a bit of a sensitive question. So you don't have to answer it if you don't want to, and I wouldn't blame you. But we're not going to name names. But we all know the major distributors out there. How do you think they're coping with counterfeits? And do you think that they would have counterfeits in their stock?
That's a great question, and it's a fair question, and
Yeah.
it was interesting. In 2012, I believe it was, the United States Senate Armed Services
Hmm.
Committee had a major hearing on counterfeits in the DoD supply chain,
Hmm.
and they determined at that time that there was a very significant problem, and began digging into it. Well, by 2012, the industry as a whole already recognized that that was a problem. There were a couple of trade organizations that already launched their own standards for inspecting parts bought on the open market or the gray market to try to mitigate this problem. So at that time, authorized distributors were repeating the mantra that the only way to avoid counterfeits was to buy strictly out of authorized distribution,
Hmm.
which is a reasonable assumption. The
Yeah.
problem at that time in the early 2000s was that there weren't any real standards governing authorized distribution behavior. So
Hmm.
risks began increasing, and we began to see through the supply chain situations where A customer may have bought counterfeits from a broker and then returned those parts back to their authorized distributor under an RMA without any safeguards in place or standards driving that. The authorized distributors would receive that RMA back into their inventory and then gladly resell those parts again into the market. There are standards now that govern the behavior of authorized distributors to ensure that those counterfeits are no longer reintroduced to the supply chain through their RMA practices.
So do you think that in the case of the ejector seat failure, did that occur with parts after those regulations came in?
That would be totally speculative, and
Right.
specifically because it's not uncommon for an organization to buy parts and then mothball them for quite a while before they're actually going to be used.
And so those parts that were curated for that project or product could have been sitting around in the warehouse for like 10 years before they were finally put into use. But and they assumed that because they've always been in DoD storage or wherever it was stored, it therefore must be, legitimate and it must be okay. But of course, we find out that 10 years ago, someone made a stupid design purchasing mistake, or someone down the line was trying to fob off some chips that were not authentic, and eventually creeps its way into the product in the future. Because I think that's a really big problem that the things like I think the defense industry struggles with, which is that if they build let's say like a fighter jet, they have to make sure it's going to be serviceable for the next 20-30 years because it could be used for a very long time. So you have to stock all these parts before they go out of sale or out of stock, and then they become made what's the word, I suppose, end of line,
Obsolete.
So obsolete. So you have to buy all these things beforehand, and then you find out that everything you bought 20 years ago was probably counterfeit at some point, and now it's completely ruined every single piece of equipment you've made ever since. So with that said, how is the DoD and defense industry supposed to cope with something like that?
That's a very huge challenge that they're trying to address right now. But to be clear, it's not just DoD. There's several industries whose products have a lifespan that far exceeds what the typical component manufacturing lifespan is. The one that comes to mind most is medical devices. Within the medical community, it's not unheard of for an engineer to design a machine, and by the time it finally finishes all of its regulation compliance checks, some of the components on that board are now obsolete. And this is before it ever really
I can
got to
imagine.
market.
I can definitely, I can imagine that with all the testing those things have to go through. By the time you've got it all done, half the parts aren't even available. I can imagine the frustration by engineers. So I take it that in those kind of projects, they have to kind of build up their stock before they even get to the point where they're distributing that equipment. And of course, they have to hope that stock that they've bought is authentic and not counterfeit. And I suppose this is where Flip Electronics comes in, because if you're a medical customer, a medical engineer who's designing for that kind of field, if you need to have, let's say, a particular chip for the next 20 years, you might want to approach Flip to make sure that you've got a good, healthy stock of that to use in your future products.
Absolutely. And it really comes back to a point that I made during the previous podcast, and I reiterate several times in our ebook, that counterfeit mitigation is not something that you do at the back end. You can't inspect quality into a product. You actually have to consider it from the design phase. How long am I expecting my product to last? How am I going to manage and support it? And will my supply chain support that type of schedule as well? And it's further complicated by the fact that organizations have to be business minded. There's no denying that. A company that goes out of business because of poor financial management is no good to anyone. And if you've got a board, just say a single circuit board with only 200 components on it that you expect to survive in a lifespan of 15 to 20 years of your product line, nobody can afford to buy the anticipated 15-year consumption of every part on that board. So you're having to do a risk analysis and buy only the parts you think likely to fail, and then only as many as you think are going to fail. And then any kind of surprises that come along, throw that whole calculation right out the window. And yes, that's where having a good supply chain partner like Flip Electronics can help you, because not only can you examine their current stock position, but also what kind of relationships do they have with the original manufacturers of the parts to possibly have future production runs after the manufacturer has initially end-of-lifed that component.
So it was interesting that you mentioned about Flip Electronics making sure that or can help engineers ensure they've got a sustainable, decent supply of critical chips for many years to come for that project. Because in the last podcast where we talked to Duke Adapa about the combination of Flip Electronics and Resurgence, is that you guys can now actually buy in the wafers as well, which allows you to then package those chips as needed. So not only are people able to get the chips that they need, but they can actually store more of them at a lower price and then get them turned into packages when needed, which actually helps with the manufacturing process anyway, because those chip packages would be brand new.
Absolutely.
So it's really interesting to see how Flip Electronics has been changing itself over these years to adapt and help customers with their obsolescence issues. So I want to quickly pick up on this ebook that you've mentioned. Could you just tell the audience what this is and why they should read it?
Oh, absolutely. So the concept behind the ebook was I really wanted to get out to the marketplace a more concise idea of the scope and the problem of counterfeiting beyond just the normal publicized numbers. Simon Sinek in his book Leaders Eat Last makes a fantastic point about how as numbers scale, they lose significance. And so I included stories in there of actual counterfeit failures and situations to describe the human cost of counterfeiting, and also to help really bring into every point of the supply chain how companies can work to mitigate their risk and utilize not only their own resources but the resources available to them external to their companies on controlling this problem. I'm very pleased with how it came out. It's a fantastic looking book. It's not a long read at all. It's designed with an ADHD type person like me to be able to get through it quickly and easily and get the information that they need.
That's fantastic. That sounds like me as well. So, because obviously a massive ebook with thousands and thousands of words might put some people off, but I think it's important that, like you say, keep the content short and sweet, but straight to the point, so that it's easy to digest. But from that ebook, what I'm curious about is, what would you say is the most important point to take away from it?
Take responsibility for your own supply chain. Ultimately, that's what it comes down to. We have a counterfeit problem, not because counterfeiters are making counterfeits. We have a counterfeit problem because people are buying counterfeits. And people are buying them because they are finding themselves strapped either by their schedules or by their finances. And as I've said many times in the past, when quality is not able to be compromised on, the only two things left are speed and money. Or conversely, if speed cannot be compromised, if I have to have the parts now, I'm either going to compromise or I'm either going to sacrifice money or quality on the altar of speed. And that's where the opportunities come in.
And I suppose that so when you say about people taking responsibility for their supply chains, does that also mean that they should be extremely cautious when they even use authorized distributors as well?
Yeah, absolutely. I mean, I love the old adage of us woodworkers: measure twice, cut once. Just because somebody has
Absolutely.
performed very well for you in the past doesn't mean they will always perform well for you. Companies change, organizations change, cultures change. You have to be vigilant. The responsibility for your product lies in your lap, not in your supply chains. That's yours. You're looking for supply chain partners that are going to assist you and cooperate you and fulfill the vision you've got for your organization, but you can never absolve yourself of that responsibility.
So let's suppose that as an engineer, I'm designing a new project. I'm going to go for a microcontroller. Despite the fact that there are many distributors out there who would be not only authorized but considered respectable, you're saying that when those parts come in and you build your product, you still have to take the due diligence to make sure that they aren't using counterfeit parts.
Yes, but I wouldn't limit it to just the concern about counterfeit. And it's something that we have to be very cautious about in distribution on the words that we're choosing. There is a difference between a non-conforming part and a counterfeit part. Counterfeits contain intent. For a part to be classified as a counterfeit part, the supplier or someone in that supply chain has to intend to defraud down the stream.
Right.
So I'm saying that people need to make sure that even if they're buying parts directly from the manufacturer, they still need to perform a due diligence to ensure that their parts are conforming and not incorrect date codes, incorrect packaging, improper handling. These are all human failures that can happen even
Yeah.
directly from the manufacturer. And those parts going on your board, again, that's your responsibility. But absolutely checking for counterfeits. There's so many red flags and so much information on how to do that that it getting through the supply chain is almost inexcusable anymore.
Now, with that said, I must ask you, does Flip Electronics have an ebook on how to check for counterfeits and the common signs that you can find?
You may have just inspired the next one.
I was about to say, because I was sitting there thinking, if you haven't got it, you have got to write a guide, a complete guide to a complete counterfeiter's guide, because I think that would be quite useful for engineers. So, because I think if you break the problem down into a series of steps, it could be a guide where, you know, any engineer sort of picks it up and goes, like, step one, check this, step two, check that, and it kind of like gives you almost like a kind of a framework that you can use to quickly verify that the parts you're using are authentic. But like you say, I mean, it is up to engineers when they receive parts, they still have to check them, make sure it all works. And so I suppose while a lot of engineers out there will know how to identify counterfeits, there may be those who don't. And so I think in those situations, like you say, it's important that there is materials out there that helps them identify it, even if it's just non-conforming, but be able to identify those parts and then take action.
Yeah, and I want to make 2 points based on what you just said. The first is that it's beyond just the engineers, though, and this is really one thing that I recognize the focus here we have with our specific audience today. But most counterfeit issues have very little to nothing to do with the engineer who designed the board. The engineer lays out the circuit, he lays out the specifications, he outlines the parts list, and it's off, and it gets handed off to a purchasing team, and then from there it gets handed off perhaps to a third-party contract manufacturer, and that's where your risk comes in. The other thing I would say is as much as I love the idea of being able to make just a very concise checklist to say, here's how you can avoid counterfeits, one of the greater challenges in mitigating counterfeit is that counterfeiters are playing a game of cat and mouse. So every time we come up with a new technique for detecting them, they're coming up with a technique for getting around that. Even just in the last 15 years, I remember back in 2010, counterfeits were relatively very easy to spot because typically they were ground the top off, put a layer of blacktop on it with just a simple stereo microscope. You could see what was going on. Today, they're far more complex. In some cases, they're being manufactured on the same used equipment that was originally designed to make the parts, and they're just being used with inadequate die or perhaps inadequate software or no testing, and it makes it visually impossible to detect that.
Oh, that's actually really interesting. Yes, that's interesting. So not only do you have the issue with counterfeits with aging equipment, like in the case of fighter jets, you know, you need to stock chips for like 20 years worth of supplies. But by the time you get to sort of that 20-year mark, the machinery used to make those things also becomes redundant and available to the market. So let's say, for example, there's a silicon foundry that's setting up shop, or, you know, it's bringing in new equipment, new UV machines, all that kind of stuff. So the older stuff is going to be chucked out because it's effectively scrap at that point. Some mysterious third-party company comes in, buys that, and can then effectively replicate the process with all the old dies that didn't pass. So it's interesting how, like you say, it's not just a case of, oh, they found some chips in the back of a van, they just sort of scratched off the label and redone it. They can now actually build, almost effectively build the same production line that made those chips, but then just repackage the ones that didn't work, but they look almost identical to the original thing because they are made with the original systems.
Absolutely. And, you know, with industrial espionage being what it is today, what's always been considered trade secrets, for instance, specifications on the plastic encapsulation, can now be found available if you have enough money on the dark web.
And I think so. So, would it be fair to say that when you talk about buying the older machines and the counterfeit parts, I'm assuming it's going to be mostly a China problem?
China's a convenient scapegoat, and not without evidence to support the idea. However, China is not the only one. there have been several significant cases of counterfeiters, even here in the United States. Um, whether it's, for instance, Vision Tech, who was working to take used parts and quote unquote refurbish them, typically with Armor All, to try to make the part look new, and then sell it into the supply chain. I've heard stories of companies that were doing what's referred to as dye harvesting, where they would decapsulate a part, take the dye out of it, say a commercial rated part, and then re-encapsulate it and remark it as an industrial or even a military grade part and resell that. So the problem isn't strictly Chinese; it is worldwide, and
it just so happens that China is the easy one to point your finger at because it's probably more obvious in the way that that I would suppose that kind of espionage is more wider scale there, and so it's easy to spot. But like you say, the ones in the West might be harder. And I just want to quickly pick up on a point that the amount of effort to take a chip, decap it, put it in a new package, including all the wire bonding, it's absolutely unbelievable the amount of effort and the technical skill required to do that. This is not one person sitting in his garage with a few bits and bobs here making a few quid on the side. This is fraud on a commercial scale. To do something like that and then to have multiple. Do you think that the staff members in those companies would know exactly what they're doing?
I think in some cases they may, and in some they may not. Ultimately, obviously, it's a leadership problem. I'm a huge proponent that every problem starts at the top. But I also do believe that in some cases, you're going to have just factory workers who are just doing what they were told to do. And so they may not have any clue what's going on. Because to be clear, counterfeiting is defined by the intent of the person to defraud the downstream downstream customer. So, there are practices that are red flags to indicate that your parts may be counterfeit, including things like reballing a BGA part. But reballing is a perfectly legitimate practice for, say, an aged part that has some oxidation on the leads.
Yeah.
So you want to reball it to ensure that your production line runs fine. And dye harvesting is not in and of itself illegal activity. It's when you repackage it and then represent it as something other than what it is that then makes it fraudulent and therefore counterfeit.
When you say dye harvesting, do you mean like taking old parts and taking the dyes out of those chips, out of those packages?
Absolutely, yeah.
And I take it the benefit of doing something like that, as a legitimate benefit, could be like buying up old stock, taking the chips out for storage, and then repackage them in the future when you require them again.
Yes, or alternatively, you may find that you want the functionality of a part that only comes in an 8-pin SYC, but your board diagram requires a 6-pin pad. So you harvest the die, rewire it into a 6-pin package that fits your board design, and off you go.
But the cost of doing something like that must be astronomical, surely.
Oh, I would expect so. And again, it's a business decision, but when we think about the amount of effort that it takes to counterfeit a part, and die harvesting is a good example, it is a tremendous amount of lift technologically and skill wise. But the pricing difference between a commercial grade part and a military rated part is also very significant. And at scale, it becomes significant enough that it's worth it.
But then that means that you've got I fail to believe that you could have an entire business because there's no way, like I said, there's one person sitting in a garage doing decapping chips. It's not that. It's got to be an entire business with working systems and payroll and accounting and stuff. It's such a huge operation. So I really struggle to understand how that could even be a thing for a company to essentially form itself on the principle of we're going to defraud people on these chips. That is honestly phenomenal.
I don't imagine that anybody woke up one morning and said, you know what, I think I'm going to create a company to do just that. I suspect that what happens is along the way, they're working for someone else, or they've got a legitimate distribution business or aftermarket manufacturing business. And somewhere along the way, they think, wow, you know what, we could use this same skill set to do this. And then they break into it. And then it becomes a dominant financial investment and revenue generator.
That's really hard. I mean, I suppose what you're saying, yeah, like it's baby steps, and it could be it could very well be baby steps towards it.
Mm-hmm.
So, like you say, you start off with a legitimate distributing service, and then eventually you sort of tease the idea of maybe selling slightly grey components for a good profit margin, and then it gets worse and worse, and eventually you get to the point where you're just decapping things and putting them in new packages because like you said yourself, the profit margin is so massive.
Yeah.
The trick then is that you have to try and get those parts into the industry without it being blatantly obvious that you're just providing counterfeits. So instead of selling those parts directly to defense contractors, you might try and get it into distributors or somewhere else and get it mixed in with a bunch of other authentic parts. So one every 3 parts becomes counterfeit or something. So it kind of becomes harder to spot.
Yes, absolutely.
And so it's just really interesting to think this through, because it's such a it's just, honestly, it's absolutely horrendous to think that someone is going to do that in the first place. And like you say, as we saw with the fighter jets, people can die.
Yeah.
You go on.
I think that what makes it so hard to conceptualize, and what a lot of people struggle with, and perhaps why here we are 30 years after counterfeiting really hit the stage in the electronic industry, we're still dealing with it, is none of us wants to believe anybody would do this willingly. But the news is full of examples of otherwise. For as long as there's been a product, there's been somebody trying to make more money off of it than somebody else. And greed is a horrible but powerful motivator. And ultimately, at the end of the day, that's what drives this.
And I think it's also interesting to note that the level of intelligence required to work with integrated circuits, it's not something your average person on the street could deal with. It's a very high-end tech. It's a high-tech, high-end industry. So you've got people out there who are as intelligent as that, who will then, like you say, powered by greed and motivated by greed, they will then use that knowledge to then defraud companies. It's honestly hard to comprehend that someone that intelligent would do that. Not because the chances of getting caught, I would imagine, is relatively high, but I suppose that actually my next question is, what is the chance of getting caught if you do counterfeit parts?
I think it depends on the market that you're selling into and what it is you're counterfeiting and just how good you are at doing it. The fact that conservative estimates right now are that somewhere north of 1% of all of the electronics in the supply chain right now may be counterfeits. When you think through the numbers, it becomes terrifying in its scope. I mean, last year we did over 1 trillion units in the electronic industry, almost $600 billion in revenue in electronics. So 1%, you're now talking about tens of billions of parts in the supply chain that may be counterfeit. How do you catch that? And if I go back to my example earlier of you're an engineer who's designed a PCB and you've got, just say, 100 parts on your bill of materials, how much time and money are you going to spend inspecting every single one of those parts? And so it just becomes a risk mitigation, risk benefit analysis of how far do we go to stop this? And as long as there's an opportunity, there's going to be somebody out there trying to take advantage of that opportunity.
In the case of the numbers, would it also be safe to assume that certain parts that are counterfeit will inherently have less risk to a design than other parts? So, for example, a standard off-the-shelf 0603 surface mount capacitor is less likely to cause a problem than something like a microcontroller being counterfeited.
Yes, less likely to cause a problem, but not necessarily less likely to be counterfeited.
Yeah. Oh, yeah, of course. Yeah.
It's actually the parts like the 0603 capacitor that, from a counterfeiter's perspective, assuming they have the technology, are more likely to be counterfeit because they're less likely to be scrutinized. People are
they're also simpler as well, I suppose, so they're easier to manufacture.
Yeah, exactly.
To manufacture, sorry.
Yep. The technique you talked about earlier about 1 every 3 parts in the batch is counterfeit and the other 2 are legit. It's a technique referred to as peppering, and I've seen that several times in my career, where you'll go down a reel of parts, and maybe there's 5,000 parts on the reel. The first 1,000 are 100% legitimate, and then they start peppering the counterfeits in the middle of the reel. because they're
Goodness me.
anticipating human nature being, I'm only going to look at the first few on the reel, and if they all look good, I'm going to assume everything on the reel is good.
And the only way I would try and get around something like that would be if I had a pick and place machine with a reel of 5,000 parts. I would have it so that every time the part comes off, it obviously gets imaged before it gets used. But then that just incurs time on the production line, because it's going to take a while to look at that image, figure out if that part's counterfeit, because that's going to require some additional computing resources. And like you say, eventually they're going to get so good that even a computer's camera is not going to really be able to pick up the difference between a fake and an authentic part.
It,
And so I do wonder if there's going to be a point in the future where people can only do so much due diligence on their side, because fundamentally they can't control what goes into the supply chain.
yeah, and we've been at that point and beyond for quite a while now. There is only so much that a human being can do, and there's been several very interesting and exciting developments in the realm of counterfeit mitigation. Everything from automated visual inspection techniques, the use of acoustic microscopy. There's been several proposals of different ways to try to avoid it. Blockchains on the radar right now. In the past, there were things like plant DNA to ensure that every single part was marked with a unique marker, so that then ideally you could go back and confirm that the parts you have are legit. But all of these things carry their own versions of cost, whether it's actual dollars or time. And it's finding that right balance that the market will support, that the industry will support, but at the same time will allow us to continue to meet the demand that seems like every single day is getting shorter and shorter.
And with all that said, what would you say that is the biggest challenge that Flip is currently facing in the realm of counterfeit parts?
I think
it's a tricky one.
I think it's just education. As a distributor, Flip has taken some pretty significant steps to mitigate our own exposure and therefore our customers' exposure to counterfeits. We've been revolutionary in our relationships with the OCMs, so the original component manufacturers. Our approach to addressing the obsolete and end of life issues that every user faces, including things like joining with Resurgent to have post-production manufacturing available. But I think it's getting people to understand the real scope of it, of counterfeiting, the real cost of it, and taking it seriously. And that's a lot of the motivation behind the ebook, was to try to get more information out so folks can make better informed decisions about how they're going to address counterfeiting within their own organization and set themselves up for success in the future for their product lines that they're designing and developing today.
And so in the case with Flip Electronics, by making those partnerships with the OEMs, the risk of counterfeits is very, very slim, because unless you can't trust the original manufacturer himself, themselves, which is, I would imagine, quite unlikely, compared to a distributor. So in other words, Flip is not buying from a distributor. Flip is buying from the manufacturer. There is no one else in between that supply chain. So you have complete control over what essentially comes out of that factory. And so by doing that, you carry on. Sorry.
When your supply chain is only 3 links long, the risk is very minimal. Very minimal.
Yeah. And so you'd have to either not be able to trust Flip or the OEM in order to end up finding a counterfeit part. So compared to, like you say, and that's interesting actually, because with distributors you could have very long chains. It could go from one warehouse to the next warehouse, because even I would say that even a part in transit is also potentially vulnerable to counterfeiting, because it could be removed off a van, replaced with another one. No, I know it might sound a bit of a conspiracy, but I mean, imagine if you're shipping 10,000 CPUs and they're each valued at like £1,000. That's a huge amount of the value of those goods is immense. So it could be worth someone's time to pinch a few of them off the back of the truck and replace them with subpar parts, knowing that they could sell the other ones on the side.
Without naming names, there was a very very interesting story back in 2011 of a manufacturer over in Asia that had an entire cargo truck stolen full of components. And within 6 months, the industry started seeing those components showing up in the marketplace as resold. And by technicality, those parts were counterfeit because they didn't carry the manufacturer's certification.
Yeah.
They didn't carry a good supply chain provenance. So it's not conspiracy theory. It's happened. Trust me.
And
As reasonable people, anything we can imagine, a criminal has already tried and is coming up with newer ways of doing it.
And so really the business model for Flip Electronics should be not how to prevent counterfeits, but how to make them yourself with the next ebook.
No, thank you.
It turns out trying to fight the fight is too hard. So instead we're going to join them. If you can't beat them, join them.
I've made the joke several times. I would not look good in an orange jumpsuit. So no, thank you.
Oh, brilliant! But like you say though, with the current ebook you've just released, it gives people a lot of in-depth information about the dangers of counterfeits and how you guys are really trying to fight against it. And I suppose I would also ask then, kind of, it does seem to paint a bit of a picture though that it's really hard to trust even authorized distributors if these counterfeit parts do pop up in their through their sales. And it does make me wonder where or how they are personally mitigating these situations, because it's easy for Flip to mitigate against counterfeits by only dealing with the OEM. That makes complete sense. But if you're a distributor and you could be buying parts from other distributors who then buy parts from other distributors, so you can't really guarantee that supply chain.
So there's a concept in safety that most people have a hard time wrapping their heads around, and that is safe is defined as having zero risk. When you apply that definition, you realize that almost nothing we do in life is safe. Everything carries risk. And so as human beings, what we do is we spend our days in a constant stream of risk-benefit analysis. What's the risk? What's the benefit? Am I willing to take the risk for the benefit? In that regard, when you're considering your supply chain, you have to consider what are the risks of a counterfeit entering. And when it comes to handling your distributors, if you're working with authorized distributors, even if authorized distributors are buying from each other, if there are 4 or 5 chains in your supply chain, but they're all authorized, your risk is still extremely minimal. It's not non-existent. It's not safe, but it's minimal. If you're introducing into your supply chain links that include brokers, gray market, or eBay, then your risk goes up significantly. And you still have to do the same risk benefit analysis. What's the benefit to it? Is the risk worth it? How do I move on? And I think another intent on the ebook was to help people have a realistic conversation within their organizations about that risk benefit analysis. Because if you don't have a true sense of the actual risk, you can't evaluate it properly against what you perceive as the benefit.
And I tell you what, this risk benefit really reminds me of. If I remember correctly, I could be wrong about this, but I do believe this was a fact, which was that certainly it might be the new ones as well. But I do believe that in submarines, anyone who's going to be operating on that submarine has to check every single part that's coming through. Essentially saying that, how do you say this? If I remember correctly, it was something like every sailor in that submarine will be aware of every part that's going into that submarine, so that they know they can trust it. Essentially, you can't put things into it that the crew hasn't signed off on, because obviously their lives are at risk in such an environment. And it kind of makes me wonder whether, because in an engineering project, you tend to find out, like you say, the engineer designs the circuit, but it's the purchasers who actually decide where those parts come from. And so you've got that disconnect between the engineer and those purchasing. So it's almost like that you almost need to have some kind of element of responsibility on the purchasers to say to them, look, this thing's going to be used in this application. This is how it could go wrong. Are you sure you want to buy that eBay part? And they're thinking, oh, maybe not. That might not be the best idea then. Maybe I will get it from a proper distributor and spend the money on it. Because I think there's also a pressure on those purchasers from their managers and the company as a whole to say, we have to make the most profit possible. So reduce the prices as much as you can. So they will take the risk, potentially go for a gray area. So like you say, it's not that one person is making a particular decision, but it's the combination of all their decisions put together that results in these horrendous situations occurring, because he wants it cheaper. He's found a place cheaper. He doesn't really know what's going on with the application. And they end up buying these parts, not realizing the full consequences of those parts.
Absolutely. It comes down to what I refer to as the iron triangle: good, fast, and cheap.
Yeah.
Whatever one of those 3 points you're not willing to compromise on, you're going to sacrifice one of the other two to get the one that you
Yeah,
want.
absolutely.
And I do agree. I don't think that there's any one person in that situation that's saying I'm going to do this because it's not the right thing to do. I think it's a whole bunch of people at any given moment making either ignorant or negligent decisions that lead to the catastrophic event.
So just before we wrap this podcast up, I've got a couple of more questions. My first question is, looking towards the future, what is it that Flip Electronics wants to achieve? What is it that you guys are looking to do to improve your game?
We continue to expand our relationships with original component manufacturers. We are excited about the resurgent opportunity and where that's going. As we continue to meet with our end users to find out what kind of product lines they need to extend the life cycle on, to continue to work in that, but also to be involved in the industry as a whole. We are constantly out communicating with other distributors, other manufacturers, as well as our customer base to better understand what the market needs, so that then we can find creative and out of the box solutions to meet those needs.
And just before we finally wrap up everything, for the audience out there who are watching, what would you say to them if they want to get involved with Flip Electronics?
Thank you for asking that. You can always go to our website, www.flipelectronics.com. There you can find how to contact us either by phone or by email. Also, be sure to go and get the ebook from the website as well. And you're always welcome to reach out to me and ask any questions that you've got. I'm more than happy to help.
And I would like to just very quickly say that, as morbid as the topic was, I think it's extremely important that engineers have these conversations about counterfeits and correctly sourcing their parts, because as we found out and have seen multiple times now, people's lives really are at risk.
Yeah.
So, yeah, Karen, sorry.
Failing to talk about it doesn't make the problem go away. There is no sand deep enough to hide our heads in to avoid this situation. We have to address it head on. We have to have honest conversations with it if we hope to overcome it.
Well, all I can say is thank you ever so much for taking the time to be on the podcast today. Thank you very much.
Always my pleasure, Robin. Thank you, and have a great day.